In this lesson, we're going to discover and talk about standard form. Standard form, the definition of standard form, linear equations can be written in the form ax plus by equals c, where a, b, and c are real numbers. Linear equations can be written in many different forms. Each of them are useful in specific situations. Unless otherwise instructed, use the format that makes sense based on the given information in the problem. So our formats that we've looked at so far are slope-intercept, point-slope, and standard form. Recall that slope-intercept is y equals mx plus b, or y equals b plus or minus mx. Point slope, y minus y1 equals m times x minus x1. And standard form for today is ax plus by equals c. So in all three of these, the y and the x stay the same, and you replace the other values. And so we want to work with these situations. So we have some context problems we're going to look at, and you will write the equation in all three formats: slope-intercept, point-slope, and standard form. The information provided will help us decide which of the three forms we're going to start with. Then we'll use algebra to create the other two versions if needed. When writing the equation in point-slope form, we're going to use x equals 2 if the y value, to determine the y value if there's no ordered pair given in the problem. And remember, we want to define our variables. So if we look at the Wilson, or this first example A, it says the Wilson family has 60 gallons of water at the beginning the week on the wagon, and they use $12 12 gallons per day. And so that would be a straightforward starting point and unit rate. And so I think you would agree we want to start with y equals mx plus b as our first format here, or even y equals b plus or minus mx. But first, let's define our variables. So the y value, the dependent, okay, x is independent. So looks like we're looking at per day here. So x is going to be the number of days on the trail, and the y variable is going to be the amount of water left on the wagon. And so again, that first equation we could write is I'm starting with y, how much water I have. Well, I'm starting with 60, and I'm using 12 gallons per day. So either this or y equals negative 12x plus 60. Either one of those would be the slope-intercept form. To write an equation in standard form, we need the x, the slope here. With that x, we need it on the other side of the equal sign with the y. So we can simply add 12x over to the other side of the equal sign. And when we do that, these cancel here. And then we have 12x plus y equals 60. And now you can see this is ax plus by equals c. The value of b here would be a 1. So here is slope-intercept format. And now we have standard form. And the third format is point-slope. And we did not get an ordered pair given to us, but remember, we're going to use x equals 2 when not. And so we don't have the y. So we're going to use the slope-intercept form to find that y value. So I can plug in my x of 2. So y equals negative 12 times 2 plus 60. And that work right there, I can simplify this side of the equal sign to find the value of y. So y equals negative 24 plus 60. Negative 24 and 60 is 36. So now x equals 2, y equals 36. Again, we plugged that in for x here. We now have our ordered pair of 236. And our slope, remember, was negative 12. And so we can write our equation now for point slope. Y minus 36 equals negative 12 and x minus 2. And so now I have three formats: slope-intercept, standard form, and point slope. So let's look at example B. The Gilbert family has 124 pounds of coffee left on day 26, and they use 1 pound of coffee per day. Let's first figure out our two variables here. So we're looking at our unit rate is per day, so that's going to be our x-axis, so number of days on the trail, and the y variable would be the amount of coffee remaining, or pounds of coffee remaining. What I notice here is that we got a ordered pair. On day 26, we have 124 pounds of coffee, and we are given the unit rate of negative 1, because I'm using 1 pound per day. And I think you would agree with this information, it would be easiest to write our point slope equation first. And so y minus 124 equals negative 1 times x minus 26. And so that's our first answer. And now to create the other equations, remember if we have an equation in point slope, we can solve for y and get slope-intercept form of the equation. And so to solve for y, I'm going to go ahead and rewrite this equation. Y minus 124 equals negative 1 x minus 26. So to solve for y, we first need to distribute on the left side. And so y minus 124 is going to equal negative 1 times x is going to be negative x. And negative 1 times negative 26 is a positive 26. And then I simply just need to add 124 over to the other side to get y by itself. And so y equals negative x, and 26 plus 124 is 150. And so there is slope-intercept form, and we can quickly and easily translate from slope-intercept form to standard form by moving the slope in the x to the other side of the equation. And so if I wanted to get that negative x to the other side, so the opposite of a negative x would be plus x. I would do that to both sides of the equation, and add that over, it would cancel. And I would have x plus y equals 150. And so now I have standard form as well. AX plus BY equals C. All right, in our third example, example C here, each ox requires 5 gallons of water per day. Each horse requires 2 gallons of water per day. The Smith family has 50 gallons of water for their animals. And so this would be a situation where we do not have a specific independent and dependent variable, but our two variables would be the amount of ox in our family and the number of horses in the family. And so I'm just going to reference x as the number of oxen because that's the first variable mentioned in the word problem, and the number of horses is going to be y. And so again, you could flip these, but standard convention is just to list the first variable as x. And so when we're in this situation, standard form is going to be the easiest format to start with. And so ox require 5 per day. So 5 gallons times the number of ox I have plus 2 gallons times the number of horses I have, it is going to equal 50 because that's the amount of water I have for those animals. And so again, this is standard form. AX plus BY equals C. And we could easily now solve for y by subtracting 5x and dividing by 2 to get y by itself, and that would create slope-intercept form. So I'm going to rewrite this equation, 5x plus 2y equals 50. And I'm going to subtract 5x from both sides. And again, getting y by itself is slope-intercept form. So that cancels out. I'm left with 2y. Now on this side I have 50 minus 5x. If either way you prefer, you can write 50 minus 5x, or you can say negative 5x plus 50. Just realize these are not like terms, so you would write them just like this. And now to get the 2 to the other side, 2 times y, the opposite is to divide. So we're going to divide everything on this right side by 2. And so I'm going to go ahead and write these as separate fractions. So negative 5 divided by 2, I'm going to leave that as a fraction, negative 5 halves x. And 50 divided by 2, though, does work out evenly to 25. And so now, again, we started with standard form. We solved for y to get slope-intercept. And this is a situation where they did not give us an ordered pair, so we're going to say, okay, if x equals 2, what's the value of y? So I can write a point slope equation of the form of this situation. And so we have y by itself already, and that's what we're trying to solve for. So use that formula or that equation. So y equals negative 5, plug in the 2 for the x right here, and then plus 25. So negative 5 halves times 2, this 2 is in the numerator, this 2 is in the denominator, so they cross cancel. So we have negative 5 plus 25, and that would simplify to 20. And so our ordered pair that we have here is 2, 20. And remember, our slope from the slope-intercept form was negative 5 halves. And so now we're ready to write our equation. Y minus 20 equals negative 5 halves x minus 2. And so there is point slope format. And so the lesson for today was introducing how do we write equations in standard form, just getting the idea of standard form, and being able to realize that all 3 of these equations are equivalent in all of these examples. All 3 equations are equivalent. They all would represent the same linear situation. If we graphed all 3 of these, they would all be the exact same line. And sometimes there's better ways to start an equation, and we want to be able to know which equation to use first and which meets the needs for our situation. That concludes section 16 notes.